Well, hello again, everyone, and welcome to today's webinar, Adopting DevOps at Scale on AWS with VirtusaPolaris. When you joined today's webinar, you selected to join either by phone call or the computer audio. If for any reason you'd like to change your selection, you can do so by accessing your audio pane in your control panel. Also, from the control panel, you'll have the opportunity to submit questions to today's presenters by typing your questions into the questions pane. We'll collect these and address them during the Q&A session at the end of today's presentation. If for any reason we could not get to your question, we plan on responding to each of you personally through email. The deck will be available through SlideShare along with a recording of the webinar 2 to 3 days after the conclusion of this presentation. So please keep an eye out for that in email. My name is James Forrester of AWS, and I'll be your speaker and moderator for today's webinar. So today we're here to talk about adopting DevOps at scale on AWS with VirtusaPolaris. As I mentioned, I'm James Forrester, Principal Solutions Architect with AWS, and I'm joined by Arti Sani, Senior Director of Technology from VirtusaPolaris, Jim Pressler, Associate Director of Technology, also with VirtusaPolaris, and Shaun Nandi, CIO of Dow Jones, News Corp company. So our agenda for today, firstly we're going to talk about the AWS DevOps solution overview. Then we're going to go into some challenges, solutions, and pillars of DevOps adoption at enterprise scale. We're then going to talk about the VirtusaPolaris DevOps pipeline approach, the News Corp DevOps success story, and lastly, questions. So to kick us off, I'm going to talk about DevOps on the AWS cloud. What we're seeing with our customers are that traditional development models are increasingly obsolete. Business is becoming more software-driven, and end users are expecting both continuous improvement and stability from applications and application portfolios. IT needs to be able to provision infrastructure as rapidly as developers demand it, and an organization's pace of innovation is increasingly and largely constrained by their ability to develop applications. This is where DevOps can help. We see that DevOps practices enable companies to innovate at a far higher velocity for their customers. The kinds of improvements that we're seeing is increases in business agility, application stability, ability to meet customer demand, more time to spend on innovation, and improvements in security. At the same time, from DevOps, we see decreases in the length of development cycles, time to market, deployment failures and rollbacks, time to recover upon failure, and reductions in operational overhead. At AWS, we provide infrastructure on demand for DevOps, which allow resources and tooling to enable common DevOps practices. Infrastructure as code, microservices, logging and monitoring, and continuous integration and continuous delivery are the 4 pillars. Firstly, let's talk about infrastructure as code. This is the process of replacing traditional infrastructure provisioning and management with code-based techniques. So what do we mean by that? Provisioning servers, storage, and networking capacity you need on demand. Deploying independently as a single service or a group of services without risking deployments to other services. Making configuration changes repeatable and standardized so they can be done over and over again. Building custom templates to provision resources in a controlled and predictable way. And lastly, using version control to keep track of all changes made to your infrastructure and application stack for ease of auditing. The second pillar is microservices. Building applications as a set of small services that communicates with other services through APIs. Building services around the business capabilities you require, scaling them up and down as required with virtually no notice, making configuration code changes repeatable and standardized, and working in an API-driven model, which enables the management of infrastructure with language typically used in application code. What's the result? This frees developers from manually configuring operating systems, system applications, and server software. Moving on to the third pillar, logging and monitoring. This is how we capture, categorize, and analyze data and logs generated by applications and infrastructure. We help you maintain visibility and auditability of activity in your application infrastructure. That lets you assess how application and infrastructure performance impact end-user experience. Lets you gain insight much more rapidly into the root causes of problems or unexpected changes and helps take out the guesswork. It supports services that must be available 24/7 as a result of continuous integration and continuous delivery, and creating alerts based on thresholds you define. The last pillar is continuous integration and continuous delivery. Rapidly and reliably building, testing, and deploying applications while improving quality and reducing time to market. How you model and visualize your own custom release workflow, letting you automate deployments of new code, improving developer productivity and delivering updates faster, helping you find and address bugs quicker with more frequent and comprehensive testing, and storing anything from source code to binaries using existing Git tools. So how do we summarize the benefits of DevOps on AWS? Automating systems operations, getting started quickly and paying as you go, improving visibility and security, leveraging fully managed services, no infrastructure to manage, and scaling without infrastructure constraints. So with that, I'd like to hand it over to Arti Sani and Jim Pressler from VirtusaPolaris to talk more about adopting DevOps at enterprise scale. Arti?
Thanks, Jim. Hello, everyone. This is Arti Sani, Senior Director at VirtusaPolaris. In this section, we'll go over some of the top challenges in adopting DevOps at enterprise scale and the solutions to overcome them. We will also discuss the 4 pillars that we believe help extensively in laying the foundation of effective DevOps. We know many startups have been able to achieve tremendous business agility and resiliency by adopting DevOps. Existing enterprises are also now looking to do the same. Release new products and services faster by accelerating product dev cycle. Per product, achieve hundreds of commits and multiple integrations a day. Be able to release features weekly or bi-weekly instead of quarterly. And at the same time, be resilient. Is this all achievable? Sure it is, but not as easy. Certainly, DevOps represents a big change to the way enterprise IT does business. And it is this aspect of change which creates the common challenges. Enterprise needs to evolve their IT culture and processes in a way that works for their organization. Here are some of the key challenges that we see enterprise typically face during DevOps adoption and solutions to address them. Firstly, enterprise deployment processes are slowed down by a lot of manual tasks and handoffs. DevOps principles advocate automating as much as possible in a way that can be tracked, managed, and monitored. The reason for this is that automation increases the speed of work while reducing the human error. We recommend automation should be enforced in greenfield applications and encouraged for applications actively enhanced. Next is legacy. Unlike a startup which has no legacy system, existing enterprises need to think about them. Moving from legacy to DevOps-enabled system is a journey, and that takes time. An enterprise needs to gradually transform to disposable and consumption-based infrastructure in cloud. Furthermore, organization silos create big challenge in DevOps adoption. Establishing cross-functional teams and broadening the skill set of delivery team members are ways to increase collaboration and break down the traditional barriers. Enterprises typically perform infrequent large releases due to manual tasks and risk of failures. A self-organized team should be designed to enable effective flow of value in steady stream of releases, providing incremental value to the customer. Regulatory compliance is essential for every enterprise, and some believe it cannot be confirmed at high velocity. But in reality, it is possible for enterprises to deliver new products and services at high velocity while still satisfying their obligation for regulatory compliance by integrating compliance into the DevOps workflow. And lastly, another challenge that we typically see is disparate use of tools due to lack of visibility at enterprise level. Visibility of tools is key ingredient to its enterprise-wide adoption. And this can be achieved by harnessing the visual approach through workflows and dashboards. These are the 4 pillars that we believe are necessary to support the effective DevOps adoption: culture, resiliency, value stream, and measurement. Let's start with culture. The most important aspect of cultural change relates directly to top-down support for DevOps. There can't be a bottom-up approach. There needs to be a close alignment between IT and business leadership with common vision and goals. Next, the primary feature of DevOps culture is increased collaboration between the roles of development and operations. There are some important cultural shifts within the teams and at an organization level that can support this collaboration. An attitude of shared responsibility is an aspect of DevOps culture that further encourages closer collaboration. And lastly, organization must accept that it's okay to fail. Experimentation is the best way to progress. Second pillar is resiliency. Resiliency should be built in. Security testing should be integrated in the delivery pipeline. Security scans should be completed with every build so that problems are found sooner. Systems should be designed for failures instead of aiming for perfection. So systems have the ability to self-heal in case of failures. And lastly, compliance should also be built in the flow. By using a continuous integration server, one can log and track precisely what versions of each source code file went in a release. There can be pauses in the continuous deployment process that can allow to inspect the change going through the pipeline into the production so that any unauthorized change cannot move forward. The third pillar is value stream. Enterprise should apply lean principles and perform value stream mapping to identify bottlenecks in delivery pipeline and create solutions for them. And then apply automation to increase the velocity and reduce human error. Finally, everyone on team should have systems thinking. Each team should be aware of actions of other teams in the pipeline. The fourth pillar is measurement. Measurement is an important aspect of continuous improvement. It should be built on all 3 dimensions: people, processes, and technology. Examples include customer satisfaction, release change frequency, volume of failures, and so forth. In conclusion, we have experienced tremendous success while leading enterprises in DevOps adoption through these pillars. And we'll share one of those success stories at Dow Jones later in the session. And now Jim, Associate Director at VirtusaPolaris, will take us through VirtusaPolaris DevOps pipeline approach. Jim?
Hello, everybody. This is Jim Pressler, Associate Director from VirtusaPolaris. I'm going to discuss how DevOps tools processes can help your organization develop an approach to achieve DevOps success. Integrated processes and tools, along with devising a practical approach across the application lifecycle management, is the key to success for DevOps. Utilizing a structured and flexible approach to achieve a DevOps strategy will ensure you have a DevOps culture which will maximize success in your organization. The way this is achieved is by using the following areas of application lifecycle management below and adjusting your approach as needed to ensure maximum success. The 8 key areas are process management, agile project and portfolio management, requirements management, test management, solution engineering, software configuration and release management, field deployment environment management, and integrated development environments. These areas can be used and managed as needed to ensure the life cycle of a product application is streamlined in order to ensure maximum efficiency and execution of your product portfolio. VirtusaPolaris DevOps pipeline approach and blueprint offers the flexibility needed with fast-paced change in tools and technology. The key areas of DevOps we utilize are automation, configuration, management, regular integration, automated monitoring and health checks, and infrastructure as code. Various tools can be used in the following areas such as release management, application lifecycle management, collaboration, testing, operational intelligence, security, source control management, and continuous integration. These tools can be used and managed as needed in order to achieve maximum success in your organization. Okay. So here's a practical scenario below that showcases the DevOps approach where every part of a product application is managed from inception to retirement. This example shows how to deploy a truly global, resilient, highly available, highly scalable application that has resiliency from the infrastructure to the application stack, utilizing various DevOps tools and processes that can be brought up and functioning in a matter of minutes. This is done by utilizing the following steps below. First is to deploy the infrastructure. You can use various DevOps tools such as Jenkins, Terraform, and CloudFormation to deploy your infrastructure in your environment. Next is to deploy and configure the operating systems for your stacks. You can use various tools such as Chef and Packer to deploy and configure operating systems for your environment. Finally is to build and deploy and configure your application stacks. You can build, deploy, and configure your application stacks using tools such as TeamCity, Terraform, and Artifactory. To summarize this slide shows how you can utilize different DevOps tools and processes to enable your IT business to ramp up quickly, efficiently, in support of your business and operational goals. Scenario 2 is an example of how a DevOps solution can be used to deploy microservices utilizing Docker and containers. Microservices is a suite of small services running in its own processes that communicate via lightweight mechanisms. They're built around business capabilities, they're independently deployable, loosely coupled, and autonomous. Docker can be used to facilitate the deployment of microservices. Docker automates deployment of any application as a lightweight, portable, self-sufficient container that will run virtually anywhere. Why this helps in any environment? This enables faster delivery of your applications. They're easier to deploy and can scale more easily. It's much easier to version the applications in the containers. And finally, components can be reused as needed. Microservices are deployed into Docker containers by pulling an image from a Docker repository, build the image, and run the image in a Docker container. That's fast and simple. Next up is Sean Nandy, the CIO of Dow Jones, who will share our DevOps success story here at Dow Jones. Sean?
Great. Hi, folks. I'm Shao Nandi, CIO Dow Jones and responsible for North America Shared Services for News Corp. I'm going to give you a bit of background first on Dow Jones and why I'm here talking to you. So I won't go too far down that path, but I want to give you a couple real stories that give you some context. So Dow Jones is the largest business unit in News Corp, and we're about 130 years old. So not who you think of first when you think about cloud adoption. But we actually were one of the first, and I'll explain that a bit on the next slide. So Dow Jones has 75 offices, operate in 43 countries, sort of a classic mid-sized enterprise. And we have very different lines of business, so it's not a one-size-fits-all type of shop. We have different types of engineering teams, different types of products. Probably the product that we're the most well-known for is the Wall Street Journal. Great paper. Hope some of you read it. Hope many of you read it. A print publication for most of that 130 years, which is now also a very large digital publication. Almost 1/3 of our readers or 1/3 of the C-suite are readers of ours. 3,500 plus companies advertise in the journal. We have millions of subscribers. But that's not the sheer extent of our business. We have much smaller sites that are startups like Heat Street or Moneyish, and then we have large business sites like MarketWatch.com, which is a digital-only site, especially targeting people who follow the markets. On the other side, our business has a huge B2B component. This brings very different types of requirements to the cloud. We have a product called Factiva. It ingests almost 30,000 sources of content per day, 1.3 billion documents in 28 languages. That's a huge amount of complex processing and presentation. And we present and sell and share that data with banks, consulting companies, every type of enterprise who bring all kinds of rigorous security and compliance requirements to us. They want to make sure our releases go through extensive testing. So on one side, you have this highly agile digital business. In the middle, you have a print business that's all about reliability and stability and not changing. And on the other end, you have this B2B relationship that's very much governed and complied. And as we build new products, a perfect one would be a recent project launch for DNA, Data News and Analytics, which is taking all that existing data and making it available via API for developers and startups to go and use and leverage. Obviously, you can see the benefits of being on a cloud platform if you do that. So let's jump ahead and talk a little bit about what cloud means to Dow Jones. So we were a very early adopter of cloud. We started back in 2012, really, and just make sure we're advancing to the next slide. Back in 2012, it was still a little audacious to be leveraging Amazon Web Services for a huge amount of your compute. But we started early. We started in the digital space. And really, our parent at the time, as we moved into 2013, 2014, set some audacious goals. They said, can you save a lot of money? Can you really reduce your physical footprint and move most of your computational power to the cloud and get all those agility benefits from doing it and go do that? So nowadays, this would be, I would say, more of a typical challenge. Maybe typical is a bit strong, but it wouldn't shock you to hear it. The 2013, 2014 timeframe, people thought it was crazy. You're going to move 75% of a 130-year-old company to the public cloud, not 75% of digital, but 75% of everything. And the answer was yes. And we started that journey. We made a lot of faithful decisions. We stopped buying hardware. We stopped expanding our data centers. And I can tell you there have been some interesting results. In the last 18 months or so, we've gotten rid of almost 2,500 physical servers, which is a ton. We're well over 60% in the public cloud just for Dow Jones. News Corp's at a much higher number overall. And I'll take a simple benchmark. In 2005, the amount of power we're consuming less than that now. So that journey's gone really, really well. But one of the things that I'm going to talk about today is how do we continue that journey from sort of being a pioneer in the cloud to getting to really sort of a scalable, repeatable structure, and how VirtusaPolaris has sort of helped set some of that up for us. So I'm going to take you through a couple slides. First, some challenges. The challenges, don't take away from, I think, our amazing story, but there are real sets of challenges that almost every one of you are facing, whether you're at a small company or a large company in your attempt to move to the cloud. We've faced them. We've surmounted some of them. We still face some of them. How Virtusa sort of helped us transition to this DevOps mindset and culture, and especially by building pipelines and tools that made that happen. How AWS supported that as well. Some of the things we have to do with training and the skill sets, and finally, what the benefits are. And if we have time, I might touch a bit on what we think is happening next with cloud, and some of that's around serverless computing. So when we talk about challenges, I think it's really important to understand how the journey started, right? Back in 2013, 2012, we had a few digital teams working in the cloud. They all worked independently. It was a different world then. And at that point, you provisioned your own account, had your keys. People weren't thinking about security. They thought they should be, but they didn't quite know how. So it was a bit of the Wild West in the beginning. And of course, like most enterprises, Dow Jones reacted to that and said, how do we bring some controls and structure in? We built a really specialized DevOps team that was amazing. But what that DevOps team had to do was sort of lock everything down. And because of the structures 3 or 4 years ago, they put in place a structure that brought a lot of control, but also brought, I would say, structure/bureaucracy, right? It slowed things down. And it also meant that, many of the teams couldn't benefit from the latest and greatest bits of tooling. So what we found is a couple things happened. Some of the teams started doing manual application deployments. They weren't necessarily using CloudFormations or Chef. We didn't get all the release cycle benefits that we wanted. We had plenty in the digital space, but we moved non-digital applications, deploy something manually, you no longer get that value prop. Teams started using different tools. And that's okay if there's a need to use a different tool, but we didn't want them to use it because they didn't have access to centralized tools. We didn't have an enterprise view. And that meant we didn't really have a cohesive approach to our strategy. And that was tied to organizational silos, not needs. Infrastructure provisioning became a bottleneck, nowhere near the bottleneck you faced on-premise. Right? On-premise, you might have faced a 3 or 4 month turnaround to get something built. We were looking at days of turnaround in the cloud, but the expectation appropriately was it should be minutes, not days. Right? And finally, we had a compliance bottleneck where you build something in development, you build it how you want it, then you go to production and realize, hey, this is a B2B client. We got to think about how this is being presented to them. You have to go and refactor, re-architect elements of it. None of that was a good story. So while we saw these radical improvements from being on-premise, we weren't getting to the end state we wanted to be at. Go to the next slide. And that really sort of changed some of our thinking. So look, Virtusa joined us early in 2016, and really into this year, they helped us with a couple things. We sat down and talked through with our business unit engineers and my infrastructure and DevOps teams, as well as with Amazon and Virtusa, how should this really work, right? What do we really want to tackle? And we didn't start with a big plan that solved everything. We really went and thought about, what are some quick wins we can have? So we took a bunch of applications that were being touched already and started bringing in some automation to them where maybe the teams wanted to do it but didn't have the bandwidth, or maybe they didn't have a standard. We started using Chef and CloudFormations more consistently. We focused on consulting support to the engineering teams to say, look, using CI/CD might seem like it's slowing you down for the first week. When you get to week 2, 3, or redeploy, it's like magic, right? It really changes everything. So we built out a sort of a common set of cookbooks and opportunities that could be reused, especially for our B2B applications. We also started looking at standard templates that would help us decide, could legacy applications be migrated faster where it made sense versus simply waiting for them to be re-architected. I think the next phase as we went through 2016 was really looking at training our team also on using automation, not just for engineering and core DevOps, but also for migrations, where tool sets like Racimi and others could help us, and where we take pressure off the engineering teams to really go and build code by getting some of those legacy application migrations off their plate. But that probably led to the biggest shift that I'll talk about that's really this one on the far right, and we can probably even jump to the next slide as we talk through this, which is we sort of decided to kick off a big bang initiative in the fourth quarter to say, we need to change how we fundamentally operate in the cloud. So the way we used to operate was in a single set of monolithic VPCs. And that really made sense from a control perspective, but it meant that we picked a one-size-fits-all strategy that every engineering team sort of had to buy into doing things a certain way. What we really moved to was, let's call it a multiple account, multi-VPC structure, where we only gated and controlled what we felt we had to, how you egress and access the internet, what your default options are for deployers, but didn't prevent developers from working how they wanted. And this, fitting into the pillars that Arthi talked about earlier, right? This was not just a technical change, but also a cultural change. Telling these central administration teams, the teams I have that own IAM and billing and the console and the deployers, you're really building services for the engineering teams to consume. You want to make it easy for them to consume those services. You want to make it flexible. And if they choose not to, you want to be okay with that as long as they fit into some guardrails. So that, is something we're still sort of moving through, but there's some enablements there, right? It means that you're in a much better position to fail fast and fail often. One of the challenges we saw with a lot of our tasks in the cloud world is it's really easy to build things. You want it to be really easy to pull out of them as well. We also started talking about how to build resiliency better. So the engineering teams, they know how to build great applications, but they're often used to the infrastructure layer giving them resiliency. By pushing them to use a pipeline, it means they can redeploy their application much more easily, especially in another region. So whether you go for a hot multi-region type deployments on day one, like we do for the Wall Street Journal, or you have an application that maybe is a merit that by putting in a deployer, if you have a problem, you could, in a couple hours, fit it into another region if you had to. A lot less effort up front, but it means if you have a problem, there's a lot less pain, right? So that also helped us with things like security. By moving into these deployers, security became much less of an issue because developers no longer say, hey, can I get access to go into production and debug this thing? No, you fix it and you simply redeploy it. You do a blue-green deployment and out it goes, right? That took a lot of pressure off sort of some of the upfront testing and separation of duties and et cetera. But I'm going to keep going across this pillar structure and come back to some of those items. Automation, right? So automation isn't just about speed. It also really helps you with cost. So let's pick on deployers. We picked Terraform as our new standard deployer for the majority of our B2B applications and enterprise applications. Is Terraform the best? Look, there's always a debate. The more important decision was we picked one tool set and said, if you want to, you can use this. You no longer have to think about how to build your pipeline, how to maintain it, how to upgrade the next version of Terraform. You don't have to think about how to get keys. Take your artifacts, drop them into Artifactory. Take your secrets, drop them into Vault. You need an image for Terraform to spit out. You build a Packer-based image distribution structure. That's great. That means you don't have to think about those things. And by presenting it almost as this automation is a way to make the developers' lives easier, right? They can go and focus on the things they want to do. And as I alluded to earlier, security's happier. I'm happier from a simplified cost and operations perspective, right? But we also realize this is a slow change. We're not trying to take every team and say, move everything you built to this new deployer framework. That's not where the value add is. It's like when you touch it, when you change it, when you build something new, look for those inflection points. So last but not least, measurements, right? One big thing we were missing when we started, I think after the midpoint in the cloud journey, is we lost track of what measures, how do we measure success? I think one of the big things is, the product teams want to make our end customers and our business teams happy. I want my DevOps and infrastructure teams to make our engineering teams and our product managers happy. And what makes them happy, right? Lack of barriers, speed to market, ability, I come back to ability to fail fast, not being stuck with decisions you made. So being able to map sort of these changes we've made to those measurements really started to sort of change that storyline in a pretty exciting way. I think those metrics are pretty important. So let's jump to the next slide, and I'll keep talking about some of these benefits here and how we got to them. So look, you heard me talk a lot about business agility, but let's talk about cloud adoption. So when I started the presentation, I said we had these audacious cost goals, right? And we've actually achieved them. So we've actually overachieved on them. We've saved more than the amount of money we wanted to save. And now we're thinking about how do we sort of make sure we adopt cloud, not for the sake of saying we're on cloud, but to really start to see those benefits flowing in. And one of them has been getting things and getting them deployed to the cloud, doing it the right way. So I was working with an engineering team last year, to give a very specific example, right, who has a mandate to lift and shift with help from all these partners on the phone, lift and shift an application out to Amazon. The hardware's aging, it's collapsing. Now, they don't want to rebuild it. There's a plan to actually rebuild this application in about 12 to 18 months. So the discussion we had is how do you get your SQL Server database out there, right? Do you simply go and install it in an EC2 instance? Do you go put it in RDS, which I'm a big fan of, by the way, which means a lot less operational overhead? Is it worth that change for 18 months? Is RDS really that scary a thing? I'll tell you it's not, by the way, in most cases. And then the third question, which is perhaps the most exotic, is, okay, we're going to use RDS. That's great. What really helps us from a TCO and support perspective? Is it going and having a DBA or a developer manually set up RDS via the console? Or do we write a Terraform script to automate the deployment? By the way, if the application is going to be alive for 7 to 8 years, it's a no-brainer. You script it. If it's around for 18 months, the initial thinking the engineering team had was, why am I going to spend 2, 3, 4 hours scripting this? Let me just go do the installation. And sort of the discussion we had is, but don't you have to set up a dev environment and a QA environment and a production environment? And I know it's going away in 18 months, but what if you discover that you want to move to another region in that period, or you have some sort of event and you want to redeploy it? And so we talked about that upfront investment and what that meant for TCO, and we decided to use RDS with scripting. Made a lot of sense in that case. So the other piece of this is these conversations that we like to have with the engineering team. We can only have so many of them. How do we pick and choose them? One of those is having better visibility to the workload. So I didn't talk much about this, but we have a pretty sprawling Amazon environment, not in a bad way. We are many, many, many thousands of EC2 instances, RDS databases, and objects out there. How do we look at them? We happen to use a great tool called Cloud Health. We use the Amazon dashboard where it makes sense. And one of the things that's happened with this sort of new DevOps approach is we've done a much better job of doing things like tagging and categorization of assets, so that we can go and quickly make decisions and understand what's consuming engineering time, what's consuming cost, what's driving risk, what applications haven't changed in a long time, and why. Are they orphaned? Are they abandoned? So that visibility gives us, again, help with where do we put our limited consulting efforts? How do we get more secure, right? Something hasn't been touched for 3 years, probably hasn't been maintained properly, right? Where do we have big cost drivers that we can save money to go reinvest in our people? And all of that, again, comes back to the improved usability of the workflow, which I already talked a bit about. But what you can see is the last bullet on this page is really improved operational cost. Well, I can't trivialize that at all, right? All of these things help you with cost, but we don't start with them. We start with agility, and the cost benefits come naturally. What we always try to stick with, and where Virtusa has really been good about sort of keeping us on track, is thinking about the fact that there's cloud cost, there's people cost, right? If our people have to spend 100 hours doing something that could take 20, it's a lot of wasted resources. There's product cost, right? If we can't fail something fast and have to keep running it for a year, that's very painful. All those sort of come back together to tell the story. So I'll move into my last slide and talk a little bit about how things have changed for us from sort of adoption perspective. And I'll tell one more little story, right? So we had a great application. It's sort of our what we call our acquisition journey, but it's our subscription system. Look, this was built out on Amazon years ago. It's a digital app you'd expect to be in Amazon. But just being on Amazon didn't make it something that was, I would say, truly DevOps, right? And about 6 months ago, we rebuilt the application just under 6 weeks, and they really moved to the pace about a release every week. They can push code very comfortably, and the way they do that is they do blue-green deployments through an automated deployer workflow. It's all the stuff you read about. But what I wanted to say around this application was it wasn't setting up the infrastructure to do that was hard. It was changing the developer mindset. So, they have a really talented DevOps person attached to that team. And I don't like to talk about individual DevOps folks. Every developer should be DevOps, right? They should be able to get their hands into the operational world. Every ops person should be writing a little bit of code, because you don't go install VMs manually via screen anymore, right? You don't go hit next, next, next on the Windows installer. You're doing it hopefully by a pre-built script, whether it's in Terraform or Chef or CloudFormation. But that cultural change to do this is the hard part. How do we get that really talented individual to spread their knowledge to the rest of the team? And how do we change the perception amongst our partners in the business that tech could and would make changes really quickly without causing a ton of breakage? And these tool sets like blue-green deployments really let that happen, really enable that to happen. So look, I think that's a typical example of exciting story. I'll say, the ongoing challenge is going to continuously be how do we not make shortcuts but still respond to the business really quickly, because I think we've learned that lesson pretty painfully. So look, the last thing I'm going to talk about before we go to Q&A is just, and I didn't build a slide for this because I think this is a pretty dynamic topic, but where are we going next, right? So I told you where we started, sort of manual deployments, a bit of the Wild West, then a lockdown, perceived to be bureaucratic structure. Now, then we moved to, really doing cloud formations and Chef, and now we're moving to sort of this multi-VPC heavy automation model. First, in the short term, we see a lot of automation coming to that VPC model. So when we would build a new account in VPC for a team to say, hey, if you want to have a space to operate, we're going to do that, We started by saying it takes about 2 months to do. And you go, why 2 months? Well, you have to plug all the deployers in. You have to take our direct connect and plug it in. You have to build new security groups. You have to provision accounts. You have to make sure it can reach vault. Ton of manual work, right? We brought that 2 weeks down, thanks especially to our partners at Virtusa, but along with our engineering teams and my team, down to about 2 weeks. So now we can build a new VPC or account for someone in 2 weeks and have it ready to go. That's a huge improvement. You know, our engineering leader in B2B told me last week, I think it should be 2 days. And I said, I think you're absolutely right. So we're looking to build further automation in that space. We're using things like Lambda. We're using automated policies. We're using Python code. We're doing a bunch of things, right, in that space. The other side of that is policies, right? We're building automated policies on top of these zones. This is also sort of the next step, so that people don't have to think. So we built this policy automation engine that uses Lambda, it uses AWS config, and it does some things that are really simple. Shut down instances that are tagged a certain way at night. Some things are far more complex, right? Look for underutilized instances, come up with recommendations, and send them to us. We really want to be very prescriptive about following what I'll call simple guardrails. You launch an instance that's untagged, we're going to destroy it, right? You have an ELB that's unattached for 3 days, it should get destroyed. That makes sense. If you need an exception, tag it a certain way, and then we'll know. Nothing will happen. So those are the short-term changes. In the medium to long term, 2 big shifts. First is containers. We're still getting our heads around it. We've done some early container deployments. We haven't picked a standard container management engine. There are a bunch of great ones out there, right? There's Amazon DCS service, there's Docker, there's Kubernetes. We're still learning and exploring. The other side is serverless, and this is something we're really starting to embrace, which is whenever possible, why do you really want an underlying VM to maintain? Can you write some code in Lambda? Can you use PaaS services like Kinesis? Can you go and leverage RDS so you don't care what the underlying instance looks like? So either it never has to be patched or it's a point-and-click patch. And look, the exciting thing for my team is the more of this we do, the more time they can spend building new stuff in conjunction with engineering instead of sort of being stuck in the day-to-day slog of, you know, patching, maintaining, et cetera, et cetera. So all that being set aside, I'd like to open it up, I think, to questions at this point and hand back to the team. And please ask a bunch of them. The only request I'll make on top of the panelists and organizers is if you give us some context in your question of what sort of level you play or role you play in the organization, because I know there's probably some developers on, there's probably some engineers, some SAs, some classic DevOps folks, right? They'll probably help us answer your question. That's it for me.
Thank you, Shaun. This is James. We have a number of questions queued up here. The first one is from Con Herman, and it, I think, builds a little on what you were just talking about. The question is, are you also considering fully serverless options for developing on AWS serverless offerings? Certainly from the AWS side, you'll see a wealth of articles being published and enhancements to the what we call our CodeStar suite, as well as CloudFormation and so forth, that let you do more of the serverless deployment and serverless build using our serverless tools themselves. But I'd love to hear a little more from Shaun about how you're doing that in your environment.
Yeah, so look, I'm just going to offer a couple comments. I don't know if anyone else wants to weigh in, but as I alluded to before, absolutely yes. I think where I caution people is not on the value of serverless, but that, you know, it sounds sort of obvious when you say it, but it's not always obvious, I think, is that your application absolutely has to be designed for it. And if you're being really smart about it, you're going to design your application as many small chunks as you can. What we find is when you make that up for an investment, you get a couple benefits. One, your costs tend to go down radically because you don't have almost any inefficiency left. Two, you know, you don't have to worry anymore about that management layer. It sort of goes away, right? But the challenge is, and this is where hopefully you can lean on partners like Virtusa or your Amazon SA if you haven't happened one, or your Amazon TAM, is you need to really think up front, can my application fit into the current tool sets, and which tool set should I pick, right? Should I be building a set of small functions in Lambda, or should I be, you know, going and isolating something and building it on Amazon's API gateway, right? Because serverless is actually a pretty broad topic, and it's pretty easy to go dive into one, but it's sort of hard to answer that generically. Hopefully that gives you a bit of a flavor.
And this is Aarti. I would like to add in, serverless definitely brings in a lot of benefits in terms of putting together all your environment configuration in one piece and moving it along, it brings a lot of resiliency and success factors into the production releases. But we need to be, again, cautious of that we are not forcing into this design into something. It really has to be a use case for serverless, and then we can reap all the benefits.
James, I think next question.
Next question is from Ilsa Chappell. The question is, what DevOps team structure worked in your organization?
So that's one I can talk about for a long time, so I'll try not to use up 13 minutes. I'll try to do it in 2. How about that? First, what I sort of alluded to during the discussion was there's been an evolution in the DevOps team structure. And unfortunately, I think in the industry, and James and the Amazon team might give a different view into this, a different slant. My perspective is what DevOps is actually a pretty confused term, right? To some people, DevOps is giving my developers more operational access and letting them self-serve. I think that's actually the best definition. To other folks, DevOps is, hey, some specialized people who can come work the magic, right, for my larger development team. For other folks, I say DevOps, I almost say DevOps with a big O for operations, are my former SAs doing stuff in the cloud, which they absolutely should be. I think there's sort of a hybrid answer across the board, and just say, for us, in our journey, we started with DevOps was a small, specialized set of people who would try to do everything in the cloud they could to make developers not have to worry about it. Where we've probably evolved to in 2017, and I think by the end of the year we'll probably get another slant on this, is my operations teams have become more DevOps-like. They work in the cloud, they're starting to learn how to build recipes, but they're not truly developers. They're DevOps with a big O. And what we've done is that we have this huge, amazing team of former system administrators who can do more. How do we give them that opportunity and that growth, both with help from training from Amazon, et cetera, and they've been really embracing it. On the other side of it, we have a big group of developers who are working in modern platforms, and we've sub-selected a set of them to really be the lead architects to help guide what should pipelines look at, how does it work, et cetera, et cetera. But I will tell you, if I got to architect an organization from scratch, I'd probably make every developer a DevOps person. That would be the perfect goal. It's not a realistic goal for most enterprises, right? You need some subset. What we did learn, though, is you don't want to have a single small DevOps team that everyone has to go through. That quickly becomes a pain point, because if cloud adoption goes the way it should, they will be overwhelmed immediately. They will burn out. You will be so dependent on them. You need those experts, but you need them in a distributed fashion. You don't want to put all your eggs in a single basket.
Totally agree with Sean on that. I think DevOps principle is just increased collaboration with developers and operations. It doesn't have to be a name tag of DevOps team as such. So I think what we have achieved at Dow Jones is a combination of both. A centralized DevOps core team, which provides the guidance to the overall enterprise and provides the architectural guidelines on the central pipeline, as well as put some policies and guardrails. So we all at an enterprise level move in one direction. And at the same time, now with this new landing zone, we are empowering the developers teams. We have created accounts and landing zones for different business units. And then we have BU operations, the people who are right next to the developers, who are then helping these developers to automate their stuff. So that's where it's a win-win situation, and the central core DevOps team is no longer a bottleneck in this whole pipeline. And that brings agility, as well as we are able to comply with some controls. Over to you, James.
Thanks, Arti. The next question is from Zhao Yao. What are some of the considerations when selecting a DevOps stack? There are a plethora of choices from build engine to deploy. What should the mindset be when evaluating those different options?
I think really looking at your environment and seeing what tools you currently use and which tools you can use to build out your environment. It's really looking amongst the different DevOps tool set and picking the different tools, the build tools, the deployment tools that typically would work best for your environment and the skill sets that your environment and organization has.
I'll just answer a little bit of a cultural answer to this, because over the 4+ years, there's been a lot of different tool sets provided, suggested. Some are definitely better than the others. Some have, better enterprise support. Some work across multiple platforms. Some are easier for SAs to use. Some are easier for classic developers to use, right? What I've found is that when you mandate a single tool and say everyone must use this, you get a lot of pushback. Versus if you're successful, this is the thing, saying here's a pre-built tool set that we've vetted that makes sense for these reasons. You're welcome to use it. And if you do, here's what you get. You get a deployer that you don't have to think about, you don't have to patch, you don't have to manage, you don't have to go ask for keys, it's not painful. That drives much better adoption. It's almost taking the cloud adoption stuff that happened a couple of years ago where people were using credit cards to get infrastructure, and it makes an enterprise version of that where you're like, look, here's what you can opt into. And what you'll find is even though one developer might prefer TeamCity to Terraform to CloudFormation, very few of them will say, I want to go build my own stack just to maintain it, right? The other piece is have, when you can, a level of inclusiveness. Find those people who are interested in trying different deployer engines, right, or working with it, and suck them into your larger team. Again, easier said than done. They don't have to work for your larger team, right? So one of the things cloud does is it really breaks organizational boundary. You have to sort of honor that when you think about who picks the tools that you're going to use, right? It's not just the architecture council. How do you bring people in? We built a squad model that I'm not going to go into too much here that our CTO really pioneered that lets us go and tack on people for special projects from across the organization. I will say, though, to answer the question, or maybe give a little bit of detailed question, our default stack of the month, and I'm not saying it so that you guys don't all write it down and tweet about it because there is variation, right, as we make decisions, is we're looking to use Terraform as our primary engine. We're using Artifactory to hold our artifacts. We're using Vault for our secrets. We're using Packer to generate our images. But there's a ton of variety from over the years that we're still supporting. And, CloudFormation is certainly out there, and we're very passionate about where we used it in the past.
Thank you. Next question is from Eric Johnson, and this is for Shaun. Is your strategy/execution of DevOps at Dow driven at the enterprise level or the BU level?
Yeah, so within Dow Jones, when you heard me give the intro, right, I talked about the print business and the digital newspaper business and the B2B business, and these map back to some extent to business units. And I guess the way I'd answer the question is yes, both. So, it started at the enterprise level with that very bureaucratic structure. When that broke down, it fell into the BU level, and each BU did their own thing to some extent. And not around billing or accounts, but they're like, I'm using this tool for my set application. And this new sort of distributed BPC model that we built, this new landing zone structure that Amazon Professional Services and Virtusa helped us design, really has changed that to say, how can we find a federated model that sort of crosses between the enterprise and the BU level? And again, it's the same thing I just sort of talked about, not to repeat myself, but we've now built at the enterprise level a default set of tools and standards, and said if a BU wants to go a different direction for part of the functions, part of the time, they're welcome to. They have to then self-support it. I'll tell you, our CTO, who was CIO prior to me, right, is going to ask those engineers very tough questions around, why do you want to do your own thing? Is there a really good technical reason? Is there a really good need? That's new. It's something we're still growing and evolving into. So, and we're trying, again, culturally, to get the BUs to self-adopt that. Right? We're not trying to force it on. We want them to feel part of the solution, not stuck with a mandate.
Thank you. The next question is for Artie or Jim. Is there, and this is from Alex Yaroslimsky, is there a particular reason AWS dedicated DevOps tools, code build, commit, pipeline, deploy, and not part of your reference architecture?
I think because mostly here we found, as we looked at some of the different tools, was to find the quickest, most efficient way to deploy all our infrastructure and our stacks. And as we analyzed all the different tools, we found, initially here we used CloudFormation, but going forward, as we analyzed Terraform and looked at the capabilities of Terraform, we found that we could deploy stuff much quicker and much faster in certain circumstances. But we could still also utilize CloudFormation, since in fact it does still integrate with Terraform. So we could utilize a lot of our existing CloudFormation scripts and run them inside Terraform, as we either decide to keep them in CloudFormation and run in Terraform, or migrate over to Terraform. But we looked at it from the quickest expediency to bring up new applications, new environments, the quickest way with the best tools.
And I would like to add, there is no single tool set which is right for every organization. One has to go in and see what they're currently using and what the skill sets are. And one needs to evolve from there. And this is the journey we're talking, like last 2 years we are here. And Dow Jones was already in this, started in this in some pockets. So we had to see all the tools and what makes sense to evolve as a standardized tool set. But some enterprises who are now very new to this journey and they do not have DevOps at this time, they could definitely consider some of these new services that AWS is bringing in, and they would become very handy in that aspect, I would say.
I'll just give 2 cents here. It builds on Arthi's point, right? So a lot of this presentation, I asked Virtusa to make sure they made what they presented relevant to what I was going to talk about, so we sort of did it together. We've been in this journey for 4 years. If you had some of those pipeline tools available at the beginning of our journey or earlier in our journey, just like our business unit teams don't really want to manage how the pipelines work, I'd actually really rather not manage either. If I could have a SaaS option built in AWS, I would jump all over it, right? But it's all about the timing. When is the tool available? And I always say the story is very different if you're starting from zero tomorrow versus you started 6 months ago, 12 months ago, 18 months ago.
True.
We have time for one more, James, or are we about out of time? What do you think?
I think we have time for just one more. And the question is for Arti and Jim, and it's from Gordon Gallagher. This appears to be geared more towards a cloud-based application suite. So what sort of DevOps team would be necessary for a standalone application or set of RPM packages that form something which is not cloud-based?
So I think if I heard the question right, Shan, I'll reflect that back. You're asking what would you do if you had a set of RPMs, et cetera, that maybe was being deployed potentially on-premise or to EC2 and were not sort of designed for the cloud?
Right. So the technology, what we are talking about, like Terraform, I'll pick an example, works both on cloud and on-premise. And that was one of the reasons why Dow Jones went with this technology. So some of these technologies are available that work on-prem. And those are like Terraform is one of those examples. Chef is another one. Traditionally, everybody is using for Chef for their automation build. So we have to pick based on the scenario, the tool set, going back again to the same thing.
Yeah, and typically too, most enterprise environments, they're going to have a mix and match of on-prem and cloud environments. So as they migrate their stuff from the on-prem to the cloud, they still need to have tools that can support deployments both on-prem and also on cloud. So one particular tool that does both environments as they go forward. So it helps that migration from the enterprise, from on-prem to the cloud.
Thanks, Jim. Well, we're right on time, and I'd like to thank our speakers very much today, Arti, Jim, and Shaun, as well as all of our attendees on the end of the line. With that, we will end the call. Thank you.